Good day, everyone. I, Janlyn Martinez, together with my co-reporter Ivy Alyucud, will present to you the properties and characteristics of a material. As we all know, everything around us is made up of a certain kind of material, and this material has its properties and characteristics that made them suitable for their certain applications. At the end of this presentation, we should be able to describe what is a material, define and analyze the various physical, mechanical, and chemical properties exhibited by different materials, explore how these properties influence its performance, and evaluate suitability for specific application. What is a material? A material is a physical substance used to make things. It could be plastic, metals, ceramics, glass, or fibers. Materials have different properties and characteristics depending on what they are used for. It is essential to comprehend the differences in their properties and characteristics, especially in choosing the material in order to achieve optimum performance and quality production. So the first property is physical properties. Physical properties are those that can be observed without changing the identity of the substance. These properties concerned with such properties as melting, temperature, electrical conductivity, thermal conductivity, density, corrosion resistance, and magnetic properties. So the first physical property is density. Density is defined as mass per unit volume for a material. It is essentially a measurement of how tightly matter is packed together. The derived unit usually used by engineers is the kilogram per meter cube. And density can be calculated with the use of this formula. D is equals to M over V, where density is equals to mass over volume. At the same time, the mass and the volume can be determined using the following formula. M is equals to D times V, and V is equals to M over D. Next is the melting temperature of material. The melting point of a substance is the temperature at which it changes from a solid to a liquid. The melting point is a characteristic property of a substance and can vary depending on factors such as pressure and purity. At the melting point, they have enough energy to overcome the forces holding them together in a solid, but they're still close enough to each other to flow and take the shape of their container, forming a liquid. It is important to note that during this process, the substance chemical makeup doesn't change, only its physical state does. Knowing the melting point of a substance is helpful in understanding its purity and how it behaves under different conditions, which is useful in various scientific and engineering applications. Next is electrical conductivity. It is a measurement of how easily a material allows electric current to flow through it. Materials with high electrical conductivity, such as metals like copper and aluminum, offer minimal resistance to current flow, making them ideal for transmitting electricity efficiently. The next one is the magnetic property. The magnetic property of a material refers to its interaction with magnetic fields. Materials can exhibit various behaviors, including ferromagnetism, paramagnetism, diamagnetism, and antiferromagnetism. So ferromagnetic materials like iron retain magnetization even after the removal of a magnetic field, while paramagnetic materials such as aluminum quickly attract to magnetic fields and become magnetized in them. Moreover, diamagnetic materials like copper are weakly repelled by magnetic fields, while antiferromagnetic materials have magnetic moments that align anti-parallel to neighboring moments, resulting in zero net magnetization. Just as some materials are good or bad conductors of electricity, materials can be good or bad conductors of magnetism. The resistance of magnetic circuits referred to as reluctance. The good magnetic conductors have low reluctance, and examples are the ferromagnetic materials, which get their name from the fact that they are made from iron, steel, and associated alloying elements such as cobalt and nickel. All other materials are non-magnetic and offer a high reluctance to the magnetic flux field. Thermal conductivity. This is the ability of material to transmit heat energy by conductions. Materials with high thermal conductivity transfer heat quickly and effectively, allowing heat to flow easily through them. Metals like copper and aluminum are examples of materials with high thermal conductivity. This is why they are commonly used in applications where efficient heat transfer is essential, such as in heat sinks for electronics or in cooking utensils. On the other hand, materials with low thermal conductivity transfer heat more slowly and less efficiently. Examples include materials like wood, plastic, and insulation materials. These materials are often used to reduce heat transfer, such as in the walls of buildings to keep interiors warm in winter and cool in summer. Lastly, on physical properties is the temperature stability. Any changes in temperature can have very significant effects on the structure and properties of materials. However, there are several effects can appear with changes in temperature, such as creep. Creep is defined as the gradual extension of a material over a long period of time, while the applied load is kept constant. It is also an important factor when considering plastic materials, and it must be considered when metals work continuously at high temperatures. The next property is the mechanical properties. The mechanical properties of material are those which affect the mechanical strength and ability of material to be molded in suitable shape. First on the list is the tensile strength or TS. It is the ability of a material to withstand tensile loads without breaking. This property is crucial for things like building materials and structural components, as it tells us how strong and durable they are when subjected to pulling or stretching forces. Next is the toughness. The toughness is the ability of the materials to withstand bending, or it is the application of shear stresses without fracture. Rubbers and most plastic materials do not shatter, therefore they are tough. Malleability. Malleability is the capacity of a substance to withstand deformation under compression without rupture. Malleable materials allows a useful amount of plastic deformation to occur under compressive loading before fractures occurs. Such materials are required for manipulation by processes such as forging, rolling, and rivet heading. While tensile strength measures how much pulling force a material can withstand, toughness assesses its ability to absorb energy before breaking. The flexibility relates to how easily a material bends without breaking, while malleability evaluates its ability to be shaped without fracturing.
Hardness. It is the ability of a material to withstand scratching, abrasion, or indentation by another hard body. It is an indication of the wear resistance of the material. Hardness ranges from super hard materials such as diamond, boron carbide, to other ceramics and hard metals to soft metals and down to plastics and soft tissues. Ductility. It refers to the capacity of a substance to undergo deformation under tension without rupture. Examples are gold, silver, and aluminum. Basically, ductility and hardness are quite similar. They both refer to a metal's ability to withstand stress without rupture. However, they differ in the types of stress being applied. Ductility has to do with tensile stress, whereas malleability deals with compressive stress. Stiffness. It is the measure of a material's ability not to deflect under an applied load. For example, although steel is much stronger than cast iron is preferred for machine beds and frames because it is more rigid and less likely to deflect, thus maintaining alignment and accuracy. Brittleness. It is the property of a material that exhibits little or no plastic deformation before fracturing when a force is applied. Additionally, it is often described as the opposite of ductility and malleability. Ngunit siya ang tendency to easily break, crack, or snap. Brittleness can occur in metals, ceramics, plastics, and glass, and other composite materials. Elasticity. It is the ability of a material to deform under load and return to its original size and shape when the load is removed. If it is made from an elastic material, mubalik na iyang original size bisan pa nga nagtaas siya during katong nag-apply pa nato ang load. All materials possess elasticity to some degree and each has its own elastic limits. Plasticity. It is the state of a material that has been loaded beyond its elastic limit, causing the material to deform permanently. Under such conditions, the material takes a permanent set and will not return to its original size and shape when the load is removed. So example anay ka ng bar like steel bar or something. Kung ato siyang epiko, maglisod na tagbalik siyang original shape. So that exhibits the property of plasticity. Chemical properties are properties that describe how a substance changes into a completely different substance. Examples are atomic bonding, corrosion resistance, acidity or alkalinity, and which we will tackle in the next few slides. Chemical composition. The chemical composition of an engineering material indicates the elements that are combined to form that material. Properties such as strength, hardness, ductility, brittleness, corrosion resistance, and weldability depend on the chemical composition of the material. So, as we can see from the table that is being presented, sa second column nakasulat iyang materials, then sa third column nakalista iyang chemical composition. Example kay sa Invar, it is made up of 64% iron and 36% nickel. Then for manganene, it is made up of 84% copper, 12% manganese, and 4% nickel. Atomic bonding. Atomic bonding represents how atoms are bound to each other to form the material. Many properties such as melting point, boiling point, thermal conductivity, and electrical conductivity of materials are governed by this. It has three types. First, the ionic bonding. It is formed by the exchange of valence electrons between atoms. Second, covalent bonds, formed by the sharing of electrons between atoms. And lastly, we have metallic bonds, which is found in metals. Corrosion resistance. Corrosion is a gradual chemical or electrochemical attack on a metal by its surrounding medium. Due to corrosion, the metal starts to convert into an oxide, salt, or some other compound. Corrosion of metals is affected by many factors such as air, industrial atmosphere, acids, bases, and etc. Corrosion resistance of a material is the ability to resist oxidation in atmospheric conditions. Acidity or alkalinity. It is a very important chemical property of engineering materials. Whether a material is acidic or alkaline, it is determined by its pH value. The pH value of a material varies from 0 to 14, with 7 as neutral. Below 7 is considered as acidic, and above 7 is considered as alkaline. In conclusion, understanding material properties is vital for engineering, manufacturing, and construction. Physical, mechanical, and chemical properties determines the material behavior and suitability for specific applications. By analyzing and using these properties, engineers can optimize performance and durability, driving cost-effective product and structure development. Moreover, ongoing research and advancements in material science fuels innovation, advancing various industries. And that concludes our report. Thank you so much for listening. Have a good day.